China is moving fast. And whether people like it or not, the scale of what is happening there deserves attention. Now, a lot of headlines talk about smart cities and electric cars, but the real story runs deeper. Across transportation, healthcare, farming, education, and daily life, artificial intelligence is becoming part of the normal routine. The pace is steady, and the goal is clear. Build systems that run faster, work longer, and rely less on human effort. Start with something simple like food delivery. In many cities, drones now deliver meals in about 15 minutes. Companies such as Meituan have already completed hundreds of thousands of drone deliveries. The process runs on fixed routes, and packages drop into secured pickup boxes. Rural areas benefit as well. JD.com operates heavy-lift drones that carry between 5 and 30 kilograms. Those drones connect remote villages to supply networks that once took hours or days to reach. Transportation shows even more change. Millions of new cars in China now include advanced driver assistance or autonomous functions. A large percentage of buyers accept self-driving systems as normal. Some vehicles include AI assistants that respond to voice commands. A person can call the car from outside and it drives over without anyone touching the steering wheel. Advanced sensors, radar units, and high-performance chips allow these cars to detect traffic lights, avoid obstacles, and handle lane changes. The technology operates at scale rather than as a limited experiment. Electric vehicle makers push even further. BYD has reached production milestones that few companies match. Some models can spin in place using independent wheel motors. Others can move sideways into parking spots, reducing the space required in tight cities. One SUV can float in deep water for a limited time and move slowly through it. A high-performance supercar from the same manufacturer accelerates at remarkable speed and uses a suspension system that lifts individual wheels within milliseconds. Charging has also changed. A new high-power charging system delivers hundreds of kilometers of range in only a few minutes. Electric charging in certain cases now competes directly with the time required to fill a gas tank. Public acceptance plays a major role. Surveys show that a large percentage of Chinese citizens feel comfortable riding in self-driving vehicles. Testing programs operate across multiple cities, covering tens of thousands of kilometers of designated roads. While other countries debate regulation and safety, large-scale pilots continue to expand. Magnetic levitation trains float above the tracks using magnetic force. Test speeds have exceeded traditional rail limits by a wide margin. Faster travel between major cities shortens business trips and strengthens economic ties. Rail projects combine engineering, advanced materials, and control systems in a way that signals long-term commitment. Education also shifts direction. Schools in major cities have introduced structured AI lessons for young students. Children learn the basics of algorithms and machine learning at an early age. Pilot schools test more advanced programs. The approach aims to build technical fluency before students reach university level. The strategy connects long-term workforce planning with current innovation. Construction demonstrates automation in heavy industry. Highway projects have used fleets of autonomous haul trucks operating in extreme temperatures. Robotic pavers and rollers use GPS and digital mapping to lay asphalt on compact roads with minimal human input. Large machines coordinate through algorithms that optimize efficiency. Plans call for thousands of self-driving industrial tracks across the country. Automation here functions as part of large infrastructure projects. Airports show how biometric systems integrate into daily travel. Facial recognition allows passengers to move from check-in to boarding with minimal manual checks. Cameras confirm identity at multiple points. Processing time per traveler can drop significantly. The scale is large, with hundreds of biometric gates across major hubs. Surveillance technology extends beyond airports. Nationwide camera networks feed data into centralized systems. Authorities use facial recognition for law enforcement, crowd monitoring, and public order. The level of coverage raises questions about privacy, yet the infrastructure continues to expand. Payments also move beyond traditional cards. Palm scanning systems identify individuals through vein patterns and hand geometry. Users complete transactions by placing their hand over a sensor. The system operates in stores, transit hubs and universities. The error rate remains low and adoption grows steadily. Digital payment culture has already replaced much physical cash in urban areas. Robotics development reaches consumer and industrial markets. A humanoid robot known as Unitree G1 stands roughly the height of a child and includes more than 20 moving joints. It walks, runs, balances, and performs coordinated movements. The machine can assist with simple household tasks. Its price sits far below that of earlier humanoid models, which cost hundreds of thousands of dollars. Robot dogs built by the same company perform flips, obstacle navigation, and voice command tasks. Police and security teams test robotic units in public events and patrol scenarios. Another company produces android robots with realistic facial expressions and skin detail. Each unit requires careful assembly to achieve lifelike movement. Museums and public institutions use these robots to represent historical figures and interact with visitors. The concept blends education with advanced robotics manufacturing. Healthcare shows some of the most direct applications. Robotic systems assist with drawing blood using imaging guidance. Automated delivery robots move medication from pharmacies to hospital wards. Surgeons perform remote operations through robotic platforms across vast distances. An experimental AI hospital runs with robot doctors and nurses that process thousands of simulated patients per day. Diagnostic accuracy rates continue to improve as systems train on larger datasets. Such developments highlight how AI supports rather than replaces human medical professionals in many cases. Agriculture also benefits from automation. Large drones spray crops with precision and operate during nighttime hours. GPS-guided machines plant seedlings across multiple hectares with minimum manual labor. Specialized robots trim crops faster than human crews. Automation reduces labor shortages and increases yield efficiency. Farmers use data analytics to monitor soil conditions and crop growth patterns. Across sectors, the pattern remains consistent. AI integrates into logistics, transportation, medicine, agriculture, and public infrastructure. Instead of focusing on a single breakthrough, the strategy emphasizes parallel development through which multiple industries advance at the same time. Domestic supply chains support rapid scaling. Investment flows into chip design, battery research, and robotics manufacturing. Policy frameworks often align with national technology goals. Large markets allow companies to test products at significant scale. Cultural factors contribute as well. High smartphone penetration and digital payment adoption prepared citizens for rapid technological shifts. Urban density supports pilot programs for autonomous vehicles and drone networks. Government backing reduces barriers for large infrastructure trials. Acceptance of new technology among younger generations fuels consumer demand. Not everyone views this rapid progress as entirely positive. As AI becomes deeply connected to surveillance systems, transportation, healthcare, and public services, concerns about privacy and job disruption continue to grow. Automation increases efficiency, but it also forces industries and workers to adjust quickly. At the same time, global competition in artificial intelligence is intensifying, with major nations investing heavily in chips, data centers, and advanced research because falling behind is no longer an option. The influence of these developments extends beyond national borders. Electric vehicles, battery systems, rail technology, and digital payment platforms are expanding into international markets. Each upgrade strengthens the next. Whether through smarter drone logistics, improved autonomous driving software, faster charging networks, or more capable robotics, the progress does not happen in isolation, since manufacturing, infrastructure, and policy often move together to support large-scale deployment. Education and long-term planning reinforce that momentum. Schools introduce AI literacy programs early. Universities collaborate with industry, and startups gain access to funding and large domestic markets. Public reactions vary around the world, with some seeing modernization and efficiency, while others focus on privacy and governance concerns. The conversation continues, but the scale and speed of integration show that artificial intelligence has become central to future development. China's approach emphasizes implementation at scale. Whether in transportation, medicine, or farming, systems move from prototype to widespread use quickly. And the world now watches closely to see what happens next.